Good evening to all of you. As Radhakrishnan and Antila has mentioned in their presentation, the major issue of the paper industry or any of the process industry is, I think, the reutilization of the waste, or you can say the reduction in the energy. It is the major challenges for the, you can say, for the process industry. So, in this presentation, we have proposed some of the techniques how we are going to improve the energy efficiency of some multiple effective operator, or you can say this unit is one of the, you can say, the most energy consuming unit of this paper mill. So these are the outlines you can see. So as you can see here, this is the energy distribution of the different sector for the transport, for the industry, for the buildings and others. So you can say here, the industry has the major, you can say, the consumer of this energy. And of course, you can see the energy share of the different countries. So again, India has the share of the 9%. And 42% of the energy is sharing by the industry. And as I mentioned here, what are the difficult issues, what are the difficult challenges for the process, for any of the process industries, for the saving of the water, for the saving of the reduce the waste, reutilize some of the waste, reduce the conventional energy load, meet the new production, you can say the specification, and we will see how this can be, you can say, improved. So the key factor of this idea is energy efficiency with utilization of biomass, or you can say the renewable sources. So the pulp and paper mill, the annual consumption of the pulp and paper mill is usually 2.09 mega million ton. So as you know, the paper industry, Indian paper industry is the 5th largest consumer of energy in India. And these are the data. I am not going the details of this because the time is constant here. So the major, again, the black liquor, whatever that is, we are getting from the recovery section. This has a very good potential for the energy, and it has the energy content of about 2 heptajoule. Okay, and generally, the process industry or the paper industry, you can say, it processes 170 million per ton of the black liquor per year globally. And it has, you can say, the 2 heptajoule of the energy. So we can use not only for the boiler as a, you can say, as a fuel, but also we can convert this black liquor as a biofuel with the help of the pyrolysis method or the BLG method, black liquor gasification method. So it may be the future of, future energy. So as you can see, this is the multi-phase operator. So multi-phase operator generally using the steam consumption of, I think, 2.09, and it is the almost higher of all the units in your section. So what is the role? We are going to concentrate for using the black liquor as a fuel in the boiler for 12 to 40% to 50% generally. And it requires a huge amount of energy, huge amounts of the water should be evaporated using some steam or some energy. Okay? So these are the data, 4.5 gigajoule of data, or this power is required in order to fulfill the energy and heat demands. So these are the, you can say, this is the figure by which our team is proposing some of the different energy reduction schemes so that the energy can be saved, the energy can be maximized. Or, so what is that scheme? we have taken different permutation and combination by with the help of some, we have also integrated, tested, you can say, PTC or an LFR, parabolic collector, as well as you can say the linear fresnel reflector as a, you can say, solar energy. We are trying to also integrate the wind energy. But it is in the scenario of the simulation only. Okay. So now it is not tested on the real time. But as the simulation result gives, this is the picture of, you can say, the systematic of energy reduction schemes where the steam, whatever we are going to provide for the heating purpose of or the concentrating purpose for the liquor, we are going to, split into two parts, first and second. So this reduction scheme is known as the steam split. In similar way, whatever the you can say the black liquor is going to enter, that is going to concentrate from, backward side. In the last side, you can say, sorry. Not okay. So you can say the last line, the blue line, is going to feed the black liquor for the concentration purpose, and we are going to concentrate this. So again, we have taken the splitted the feed of you can say the black liquor, and develop some mathematical equations based on this. Okay. So different types of energy reduction schemes. Okay. And the last thing, you can say, whatever the steam is discharged from the last stage, last effect, you can say, that is also going to reutilize, and the TVC, that is thermal vapor compressor, is again used, and again that is used in the first stage. So that's, and also we have used the flash tank, whatever the condensate is coming from the last, that is also we can use as a, you can say, the feedback. Okay. So some mathematical equation can be written based on these permutation combination, you can say, the model what you have developed, and try to simulate it or try to solve that model or that equation using some metaheuristic algorithm and some artificial intelligence based, or you can say any other nonlinear programming method, mathematical equations can be solved, and that solution gives the energy efficiency, the real-time energy efficiency varying between the 4 and 3, but it is drastically increased by 50%, you can see here, by 8.138. Okay. So it is my previous published work that is published in different journals. So you can see here, I have not, in this paper or in this work, I have only shown here this, you can say, this diagram only, this configuration only. But we have discussed already the PTC and LFR, that is the solar energy, and that when integrated, when simulated, we can see here it can fulfill the demand. It can fulfill the demand, and that is mentioned here by, you can see, the PTC has given the power of 3186.8. And similarly, the LFR is giving 3186.8 kilowatt. So in this way, we can save the energy. We can save the energy of this unit, or ultimately the reduction can be done. So it is the main goal. So okay, thank you.